Hello and good afternoon. CTS267, Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this afternoon's video tutorial is going to be a tutorial and solution set and a little bit of additional lecture on the challenge number 6 activity for the TINC garbage disposal company. So as you can see here, we've got pretty much the exact same network setup with the exception of the addition of switch 4 over here. And you can be guaranteed, you can see I can't click on switch 4, so you can almost be guaranteed that there's something, there are going to be some shenanigans over here between switch 3 and switch 4, because we can get onto switch 3, but not onto switch 4. And so we'll deal with those in turn. But other than that, the topology looks very similar to the topology we've been working with previously. So let's go ahead and dive in here and take a look at, take a look at our scenario. So this is the third TINC garbage disposal limited company we're going to be working with, trouble ticket we're going to be working with here. So PC1 and PC2 clients can only sporadically access the internet. Most of the pings fail. The issue needs to be resolved as soon as possible, and I believe we should have an IP, and there it is. And also you'll see you cannot access switch 4. So here is the internet IP we're going to be using for testing. We can also see two other issues. We're going to migrate from HSRP to VRRP, so that will undoubtedly be causing problems. And then, yes, of course, switch 3 to switch 4. So something's going to be up between switch 3 and switch 4 here, without a doubt. And it looks like there's going to be an Etherchannel misconfig of some type that we'll have to deal with. But let's start at the top here. And let's go ahead and confirm, right? Always good to confirm if users are claiming, it doesn't say PC3 and 4 are having any problems. So let's check PC1 and PC2 out here. So let's go from user exec to privilege exec, and can we ping that 209.165.201.225 address? And so as expected and as reported, you can see that we're getting network unreachable as well as the period for the network timeout. Let's check PC2 out here, and let's do the same thing. 201.225. And do we have the same problem? We do. So now remember, when we didn't get a DHCP address, show IP interface brief, we would actually, when we tried to ping or to trace route, we would get that the protocol is unknown. Now you can see here that we are receiving an address in VLAN, what I'm going to assume is VLAN 11. Let's take a quick look at our job aids here. And exactly, PC1's VLAN 11, PC2 is VLAN 22, as referenced and noted here by the third octet in the IP address. And while we're here, let's take a look at what else we've got going on. Again, this is the setup is almost identical to the previous setup. We've got OSPF area 0, we've got iBGP running between gateway 1 and 2, and eBGP connectivity out to the internet. And let me take a brief look here at these connections. They are still the same, so that looks good as well. So we've got our DHCP address on PC1. Let's check PC2 out. What is our status here? Show IP interface brief. And we have an IP address, albeit well up into the range here for VLAN 22. So what should we check next? Well, let's go ahead on the PCs and let's say show IP route. And the reason we're going to do the show IP route is we should be getting a default gateway, and we are. The default gateway address is 10.0.11.1, and so over here I would expect 10.0.22.1, and we get that as well. So the PCs have their IP addresses. So that tells me that I'm getting DHCP information from the DHCP servers, or server, in this case probably router 1, possibly router 2, but again, I am receiving a DHCP address. So at layer 2, that tells me that I've got connectivity through. I'm in the right VLAN. So let's take a look here, and we're going to jump onto switch 1. So if I'm on switch 1, let's go ahead and say show IP interface brief to start out here. Again, the ports are up because I am getting a DHCP address. So my connectivity through switch 1 looks good. Let's make sure that we've got no VLAN issues here. We shouldn't, because again, we're getting the IPs from the correct DHCP server. So yeah, Ethernet 03 is VLAN 22. And a lot of stuff here in VLAN 11. 1, 2, 3, 4, 5 connections, but the job aids are showing 1, 2, 3 connections in VLAN 11. All right, so more ports in VLAN 11 than we have connections. So let's go ahead and take a next step up here to router 1. And let's see, is router 1 our DHCP server? Let's get into privilege exec and show IP DHCP bindings. And we are here, 10.0.1.11. So this should be, and was that the IP down there on PC1? Yes, okay. So the DHCP server for VLAN 11 is router 1. So we've got connectivity through to router 1, right? So everything looks good there. And so we're getting an unreachable. So I'm going to step back to PC1, and we're going to digress here for a second. Now let's run a trace route command. I want to see 10.0. I'm sorry, not 10.0. How about 209.165.201.225? And actually, let's speed this up and say numeric. So the first hop that I take is 10.0.11.2. And that does not jive with 10.0.11.1 is my default gateway. But this could be the physical IP address is my guess. Let's take a look. Show IP interface brief. Yeah, 10.0.11.2, right, because it doesn't show you the, in this case, the virtual IP from VRRP. So we do go to 10.0.11.2, but then where do we go after that? We go to 10.0.11.1.11. And then we reach that, but then we get this exclamation mark H in the traceroute output telling us that we've got some sort of an issue here. You can see that the very next step, or the very next hop, is that same 10.0.11.1.11. But where would that be? It is not going to be any of these other connections. This is the only VLAN 11 connection that we have here. So let's do, all right, so 10.0.11.1.11. How about a show IP ARP? What does this tell us here? 10.0.11.1.11. So we get the MAC address, AABBCC002800, and it shows that we're learning that over that sub interface. Now this is interesting, right? Because what's happening here, what this is showing us, is that we're learning about the MAC address for the layer 3 IP 10.0.11.1.11 across the link from switch 1. So now let's go back to switch 1 here and say show MAC address table. Show MAC address table, where is that 2800? So it is right there. It's in VLAN 11, Ethernet 2.0. Show run interface Ethernet 2.0. Show IP interface brief. That interface is obviously up. And it's one of these interfaces that's showing up here that we don't have. So what does... So now this is interesting. So we come up here to router 1, and what is... Let me show IP route. What is router 1 doing? Okay, so we have a default route that's been injected into OSPF, and it tells us that we should be going to 10.0.11.1.11. So what's happening here, and this is really odd, and now I see why they say you would have intermittent connectivity, or that you should, because we've got two equal cost default routes on router 1, one of them saying to go back down. And so here's what's happening. So let's draw this out. So, and this is pretty interesting. This is not one of these easy problems that you typically see. So PC1, when we trace out, we come up here to router 1, but then we're catching a default route sending us back down to switch 1 out Ethernet 2.0, which is not any of those interfaces there. And remember when we did that show VLAN brief or the show VLAN, we're seeing that there's 5 interfaces in VLAN 11. So we've got something here on Ethernet 2.0. Now, very simple for me to confirm if this is the issue or not. And we're going to shut Ethernet 2.0 down here in a second. But when we take a look, what we should see, I don't want yellow-green there. What we should see, let's do blue. PC2 on VLAN 22, when it comes up here, again, there's those 2 default routes. So what is it going to do? Is it going to come down this way to try to get to the first default route? And that may be the intermittent connectivity as well. So let's jump back onto PC2 here. And let's do a trace to 209.165.201.225. This is definitely an interesting one here, and we'll do numeric. We don't want to do the right. And sure enough, take a look at that. Now, what's interesting is it says there's intermittent connectivity, or sometimes it works, sometimes it doesn't. But what we're seeing here is I don't see anything successfully being able to make it out. We are going to that 10.0.11.111 address that it says we're learning via OSPF, that, and maybe a default originate statement, a default originate always statement of some kind, but there's no question that it's via this 10.0.11.111 out Ethernet 1011, which brings me back down to switch 1. And as we saw with the show MAC address table, that is out Ethernet 2.0, and that's just an access port. So again, quickest way to confirm this, let's do this. Let's see what happens. Well, maybe not the quickest, but we'll see what happens here. Let's go interface Ethernet 2.0. And so again, I'm doing, this is sort of an assumption here that I'm attacking with. And let's take down, so something is on that link or on that interface 2.0. Let's come back to router 1. And let's rerun this command to see if that drops off. And the fact that it's getting in via OSPF, and we may, I'm going to show IP OSPF neighbors. Okay. And there's the 10.0. Now you'll notice we had 1 second to go. We didn't see an error message. Yeah, so now this even gets more interesting. Okay, so we have a router ID, a node 10.0.1 or 10.0.11.111 with a router ID of 172.16.0.1 we're establishing a neighbor relationship without that sub interface. And then it goes away when we shut down Ethernet 2.0. But did I see show IP route? What I'm waiting for was to see if the dead timer. Yeah, and that took it away. So hold on. Boy, this is quite a complicated scenario here. And does the trace route function now? It does. Okay. So we've got, and let's make sure PC2 is functioning properly. Okay, and PC2 is working, and we are going out gateway 1. If I was to ping 209.165.201.225, and this is going to work. If we can trace out, odds are we can ping out, even if I was to repeat it a few times. Okay, so shutting down, so there's obviously an OSPF router on this interface Ethernet 2.0 that is not documented, not only not in the diagram, but the job aids didn't show. Let me double check this here. Yeah, the job aids show me nothing. I mean, literally, we should have 4 interfaces that should be up on switch 1, and it should be Ethernet 00, 01, 02, and 03. Okay, so the simplest thing to do, right, is that layer 2 security here. If only Ethernet 00, 1, 2, and 3 are supposed to be up, and you can see here 00, 01, 02, and 03, none of those interfaces, the 20, 21. So a couple ways we can, I mean, there's actually a bunch of ways we can approach the resolution here. What should, without a doubt, interface range Ethernet 20 to 23. Whoops, sorry about that. Ethernet 20 to 3 is we should shut all of those interfaces down. They shouldn't be in a VLAN that's active. They should be in a parking lot VLAN. So let's say switch port access VLAN 999. And again, do show VLAN brief. 999 doesn't even exist. So we don't want them in VLAN 11 because there's no reason for them to be in VLAN 11. And so that's one way, and again, not clear. Let me see what, I'm going to look at the hint, because that definitely is going to resolve the issue. Let's see, do we get like a little hint here? Devices off of switch 1, look into the routing table if you want to prevent unwanted OSPF adjacencies. Aha, you could shut down all unused ports, so that's what we did. Or configure, okay, great. So, or we can configure OSPF, but at layer 2, right, we'll approach this bottom up. Without a doubt, if those interfaces are not being used, they're clearly not documented here, we're going to go with shutting those interfaces down. It talked about some other ways to resolve the issue. The only issue I have with that is if we start attacking this from, well, we should passive the OSPF interface. And then again, that's a best practice, right? You know, passive interfaces you're not using. The problem is that router clearly should not be connected in at all for whatever reason anyway, right? It's not even documented on our diagram. So let's shut those ports down. And then let's go investigate and see why things are plugged in. So that's how we're going to approach it here. Again, you most certainly could do OSPF authentication, but are you addressing the issue of a rogue OSPF router being connected to your network? You're not, right? So you still have that router plugged in on your network, and it's still running OSPF, and it's trying to establish an adjacency. So let's shut those ports down. Let's put those into what we would call, you know, and typically here's what you would do. I would go into, you know, VLAN 999, and we would say, you know, name parking lot. I'll just say P lot, right? And shut it down. And then say show VLAN brief, and you can see here that there's VLAN 999, and it's shut down, and those are the interfaces that are in there. So that's how we'll approach that issue. And that solved our internet connectivity. So let's move on. And again, definitely wanted to look at the hint there because there's all kinds of things in play, as you could see from the possible solutions. So we've migrated the first hop redundancy protocol of the network from HSRP to VRRP. He's asking you to help him investigate why R1 and R2 are assigned the master state for VLAN 33. All right, so let's take a look here. We've got router 1. So let's say show VRRP. We could do a brief, an interface. Let's do an all here. All right, so why for VLAN 33? Group 1, group 2. Okay, so there's VLAN 33. So the state is master here, right? We've got our virtual IP 10.033.1. And again, the reason I jumped on the routers right away and not the PC is because we've been told there's a migration has just taken place. Everything's working except this VLAN 33. And so let's go over to router 2, and let's do the same thing here. Let's go from user exec to privilege exec. We'll get our password in here. And show VRRP, was it all? There it is, all. So let's take a look here at group 3. So here's group 3. And again, it thinks it's the master. We've got the right virtual IP address, the master router, authentication MD5 key string, and we saw authentication over here in group 3. MD5 key string as opposed to authentication text string, and it's showing us Cisco with that configuration. So let's do this. Show run interface Ethernet 1.1, and that's what we have for our authentication there. And let's compare and contrast. Show run interface Ethernet 1.1, and that is what we have there. So clearly, we've got what's basically plain text authentication here, where the password is, in the clear, and then over here on router 2, it's got this MD5 key string. But again, this is extremely weak. This type 7, you can cut and paste that into a multitude of websites that are going to decrypt that for you. The type 7 passwords are extremely weak. So let's do this. We're not going to use the 7. So how should we approach this? Obviously we've got to match them, and we want to use MD5. We don't want the type 7. So here's what I'm going to do. I'm going to stick with that Cisco as the password. Let's get an interface Ethernet 1.1, and let's say VRRP 3. And I wonder if we have to do authentication MD5, and yeah, we could use a keychain. We could, yeah, and I'll tell you what. Let's do that. Let's approach it from that aspect. Because we talked about this in class on Thursday, right? So if we wanted to rotate the keys and not have to worry about maybe the VRRP breaking, let's do this. So I'm going to say keychain VRRP key 1 key string, and let's go with what do we say? We're going to stick with CISC0. All right, now let's get an interface Ethernet 1.1. And do show run, is still up there? No, do show run interface Ethernet 1.1. And we're going to say no, or well, actually, we'll just override it. VRRP 3 authentication key. Now remember, MD5. Our authentication should be MD5. MD5, and we're going to say key chain. And the name of our key chain was VRRP. So let's go ahead and do that. So VRRP authentication MD5 keychain VRRP do show run interface Ethernet 1.1. Let's make sure we don't have. All right, good deal. So we've got the keychain there. Let's come over to router 2, and let's go into global config and say keychain VRRP key 1 key string is going to be C1SC0 interface Ethernet 1.1 VRRP 3 authentication MD5 keychain and VRRP. So do show run interface Ethernet 1.1. All right, so now we've got matching keychain. So we look, everything looks good there. Now again, remember we said this type 7 is pretty weak and you could cut and paste that. Well, if I said do show keychain, and this just occurred to me, or I'm sorry, do show keychain, and this just occurred to me, when you say do show keychain, guess what it shows you? Exactly. Now, we can certainly make the argument that in order to see that, you would either have to have somebody running that command and you're doing some shoulder surfing, or they have privilege access. So if I were to say exit and then disable, right? Exit, oops, sorry, let's exit and get to the end here, and then disable. So I'm enable into privilege exec, disable out of privilege exec, back to user exec. Can I say show keychain here? Yeah, you can't from user exec. You've got to be in privilege exec. And if somebody has access to privilege exec on your router, again, the least of your concerns is the show keychain command being run, because at this point they've got carte blanche to your device. So the keychains now match, and the authentication matches. So let's say show VRRP, oops, sorry, VRRP interface Ethernet 1. Let's trim it down here. All right, so the state now has changed to backup, and we've got the MD5 keychain VRRP working, And let's check on router 1, do show VRRP, interface Ethernet 1.1. All right, so yeah, it was basically a mismatch in the authentication type. We were doing plain text on one side, MD5 on the other side, and we basically just implemented a keychain, whether they implemented a keychain for the solution or not. You could do the key string as well, that would have worked, but I went ahead and did the keychain because we saw this in the in-class lab activity. All right, so that should take care of our VRRP scenario, and that was VLAN 33 clients. And so let's actually, PC3 is VLAN 33. Let's vet this. So can we ping to 209.165.201.225? Okay, we're good. What if we trace out there 165.201.225? Let's do a numeric. All right, so that definitely solved the issue. Now to the last issue, which you had to have seen this coming, right? With switch 3 and switch 4, and the fact that we have no access to switch 4, which it says right here. So there's something with the ether channel, right? So this one should be pretty straightforward. We can only see the switch 3 side. So let's go from user exec to privilege exec. Show ether channel summary is where I would start immediately. And we can see that it looks like the link interface Ethernet 2.1 is properly bundled, but we have a suspended link in Ethernet 2.0. So let's take a look at the two links that we have here. So show, or the physical interfaces. Show run interface Ethernet 2.0. Show run, and we're just doing, we're not doing any type of negotiation with PAGP or LACP. This is just simply mode on, right? So there is no negotiation, it's just mode on. So show run interface Ethernet 2.1. All right, and it should jump out right away as to why this is in the suspended state when we look at the two member ports. And now this is a common problem sometimes. Because when you create the ether channel, right? So if we were to say show run interface PO1, and PO1, that is the ether channel interface. Once you run the channel group command, right? If you've got the same interface types, all of your other configurations should be run under the port channel interface. That way, it auto-magically gets pushed down to those member interfaces, right? So, for example, if I was to come into, and you'll notice there, it doesn't say no negotiate here. On Ethernet 2.0 and 2.1, it doesn't say switch port no negotiate. So I'm going to turn off dynamic trunking protocol. To do that, I would go under interface port channel 1 and say switch port, switch port, no negotiate, wait a second. Switch port trunk. Oh, is it not going to allow me to do that? And maybe that's not allowing me to do that. Hold on one second here. I'm curious to see. That should, because we can't get onto switch 4. Let me come over to one of my switches here. And let me see real quickly, if you go into interface FA101, you should be able to say switch port no, yeah. Okay, so switch port no negotiate should be there, but it is not here. And maybe it's because it's IOL that you can't turn off the negotiation. That's interesting. All right, so let's do this. So we clearly saw the issue. If I were to say do show run interface Ethernet 2.0, as opposed to 2.1, what is the problem, right? It's supposed to be a trunk link, but here we have switch port mode access. I recently had a coworker kind of run into the same issue where they had thought that because it had switch port mode trunk on the interface and switch port mode access, that it was a trunk port. But remember, this command right here, switch port mode access, overrides the fact that the ports on a switch by default are trunk ports. In fact, how would we see that? How about a do show interface switch port? Get switch port typed out properly there. Let's get down to 2.0. So here's 2.0, right? And you can see it tells you the operational mode is static access. and therefore it's been suspended. And what's the administrative mode? Right? So the administrator or someone with administrative privileges put this into static access mode because of the switch port mode access command. And again, it overrides that switch port mode trunk. It overrides the switch port trunk encapsulation .1Q, and it makes it an access port. And so when we look here at the administrative mode, we see, what is the administrative mode? The administrative mode is a trunk, because there is no switch port mode access command applied to Ethernet 2.1. So what's my easiest, I shouldn't even say easiest, what is the proper way to sort this out? Well, let's go under the physical interface Ethernet 2.0, and let's simply say no switch port mode access, right? And switch port mode trunk. And so now let's say do show run interface Ethernet 2.0. And you can see the switch port mode access is off of there. And again, even with those two trunk commands, switch port trunk and cap.1Q and switch port mode trunk, if I was to say do show interface switch port, and we made our way back down to 2.0, you can see what is the administrative and operational mode now? It's trunk. But for me to override that with a single command, I could say switch port mode access. And this is, we're going to see, yeah, we should definitely see something telling us that, and maybe that is how they want you to turn DTP off. You should be able to say switch port no negotiate, and that turns off DTP. It's telling dynamic trunking protocol, I don't want you to try to negotiate with that desirable and auto, right, what the ports are set to if they're trying to, you know, marry up with a port on the other end. But as soon as you say, you can see we can't bundle because I've killed DTP, but more importantly than turning off DTP, right? Yeah, we turned DTP off, but what kind of a port, do show interface switch port, what kind of a port did we make this? Let's cruise down here to 2.0. We've turned it into a static access port. So remember that switch port mode access command overrides any trunk commands. Any switch port trunk commands that are on that port are automatically overridden. No questions asked, right? Switch port mode access is going to turn that port into an access port, and this is how you can verify how that is set up. So again, do show run interface Ethernet 2.0. I want to make sure we go a little deeper than, you know, hey, here's the 7 commands that you need to run to solve these issues. Here's how you validate things. Here are some of the different options. This is what you may see when you're troubleshooting. So you can see switch port mode access override switch port mode trunk. And now let's go back to switch port mode trunk. And again, I said no switch port mode access. I could have said switch port mode trunk. And what's going to happen? We should see something happen here. Do show run interface Ethernet 2.0. So we're back to trunk mode. So if I was to go into the interface port channel 1, and let's say do show Etherchannel, maybe it's not showing us anything here. Yeah, it shows it's bundled. I could say shut, and shut the port channel interface down, and then say no shut in order to bring the port channel back up, right? So do show Etherchannel summary. We should have capital P's in there showing that these are layer 2 port. Well, the SU gives us the layer 2 port status, the S specifically, but the P showing me that these are successfully bundled in the port channel. All right, well that, boy, this was a monster set of trouble tickets here. These are some good trouble tickets. So again, the first issue we had was a bogus default route, and we attacked it from a bottom up, which kind of led us up to router 1 and then right back down to the switch, where we saw that we had ports that were enabled that shouldn't have been enabled. We disabled those ports, put them into a parking lot VLAN that is shut down, so that if anybody's plugged in there, it's not going to make a difference. You could have done some passive interface work. You could have done OSPF authentication. That would have helped. We saw the VRRP problem with authentication, and then finally here with the port channel configuration. All right, guys, thanks for watching, and I will see you Thursday night.